What does legislation do out of it? So that we have a lot of parties which take care about legislation. For example, the WHO. It doesn't make directly legislation, but it gives you a lot of guidance. And here we see the limit values of IGNIRP. The, uh, they have limit values, for example, for the electric field and the high frequency range. And here you can see the typical shape between 30 megahertz. Is it 30? 27 megahertz up to 400 megahertz, where we have the load limit values. For occupational, for example, it's 63 volts per meter, and for general public, it's 27 volts per meter. Electric field strength is allowed. They distinguish between occupational and general public. I personally prefer the Australian definition because when you have, let's say, a secretary inside of a broadcasting company, he is for sure a worker, but he has no idea about RF energy, maybe. In Australia, they say RF workers, trained RF workers, for them we have the blue curve, and non-RF worker, for example, the secretary is a non-RF worker because he or she is not trained on RF fields. They don't have any kind of test equipment. So they are for sure non-RF worker. And for them, the red curve is important. And we also have countries which have a much lower limit values, for example, at 6 volts per meter or even 3 volts per meter. And I mentioned it already, some countries, they made a compromise for the population and on the other side also for the transmitting services like mobile radio. They said, look, you public, you are concerned about long-term effects, but as we don't have a proven link between electromagnetic fields and the long-term effects like cancer, we tell you we go into a precautional situation. We make precautional limit values and take the lowest limits value we have here and divide it again by the factor x by that. And we take this limit value as a quality goal, as a precautional limit value. And by this, we have those 6 volts per meter, for example, in Italy and in Switzerland, and even sometimes 3 volts per meter. And you can also see, as they don't know which is the biological effect, they also have no dependency on frequency. So it's a flat line here. Okay. If you want to know more about different countries, I can only tell you go to the WHO, to the World Health Organization. They have a big database, and there you can read out which are the limit values in France, in Finland, in Cyprus, in Cuba, in Italy, and so on. And they also have a lot of legislation, so you don't have to search through the entire internet. On the WHO page, you have there a lot of information. Many standards are also translated into English language and so on. So very interesting. They also have the fact sheet. And whenever you have a problem with people concerned about whatever broadcasting services, go to the WHO page and have a look. For many of those applications, they have fact sheets telling them, look, this is the radiation which comes from a broadcasting tower. These are the biological effects. And from here on, it's dangerous. Okay, defined on the definition of WHO, or for sure, normally also your national legislations shall tell you which limit value they apply. So we told it already. We have some kind of basic limits. For example, in the low frequency, it's a current which is flowing through your body, and the RF, it's the absorption rate. The best would be to measure now the temperature rising inside of your body, but you don't want to run around with a thermometer in your mouth. Therefore, they have made by experiments and by worst case studies, by simulation, for example, which field strength is necessary to create such kind of absorption and which field strength is necessary that you have such a current through your body. And these derived limits are much easier to measure, and you can also make yellow and black lines onto the ground and saying, look, when you walk uh, above this barrier, then you are in a range where the derived limits are exceeded, and maybe your basic limits will be also exceeded. The derived limits are always a little bit more restrictive. So when you exceed the derived limits, the volts per meter, the 27 volts per meter at 100 megahertz, for example, you can still say, okay, I have a second chance. I measure the specific absorption rate if you want to spend the effort. Okay. Finally, the basic limits are your goal. Derived is much easier to be measured. And I mentioned it, from a certain amount on, you will get those warning signs. Attention, here the radio waves are so strong, you should not enter. And many companies even do without national legislation, they do already safety rules inside of the companies. And they made access restriction, because nobody wants to have any kind of hazard inside of his company. So we can also say 100%, this is the body heating effect where you don't want to get above. 20% of this is round about the limit value for general public. So there are no procedures required. When you're at below general public limit values, you don't need any procedures. When you are above general public, but still below occupational or RF worker limit, then you need indicators like, attention, you are entering now an area. The people should have knowledge about the EMF guidelines. They should have an RF awareness training, and they should also have, for example, personal protection equipment when it is possible to have here an area where they can even exceed the 100%. Normally, nobody should go into an area where 100% is exceeded, but sometimes you must when you have to go into a transmitting tower and you can't break the power. There are protective suits available so that people can even go into a 10 times higher field strength, so up to 1000%. But I mentioned it, then you need special protective suits, but more than 1000%, they can also not protect you, okay? And above 1000%, only foods are allowed. Even we should also protect our foods, I believe.